Hi class, today I want to tell you a little bit about knowing which measures of center and spread you should use. And this is all depending on what your distribution of your data look like. And when I say spread, you might want to use the word variability. Maybe that's what your textbook says, but that's a common way to talk about it, center and spread. So I've drawn a few distributions here on my whiteboard. At the top, you can see I've got a symmetric distribution. It's got a nice hump shape in the middle, and it's even on the sides. Below that, I have skewed right. So most of the data are on the left here, and then it's spread out to the right side. Or I've got skewed left, where most of the data are on the right side here, and then it's spread out to the left. And then down at the bottom, I've just got a crazy distribution. So let's talk about measures of center and spread. First of all, let's talk about measures of center. So the two main measures of center we have are mean and median. So for the symmetric distribution, the mean and the median are pretty much in the same place. You can see the red line, I kind of drew two red lines. That's where the mean is, but that's also where the median is. So for a symmetric distribution, it really doesn't matter whether you use mean or median, because you're probably going to be reporting pretty much the same value. However, on a skewed distribution, the mean will be pushed out in the direction of the skew. So for example, for this one that's skewed right, I drew the median down here because that's the point at which half the data are on that side and half are on that side. But these values up here, these outliers up here, they really affect the mean a lot, and they'll tend to drag it towards that direction. Same thing with the skewed left. The median value will be somewhere down here, whereas the mean value, and I wrote them both below this time, but I got the median value way up here, kind of halfway between, half of it's on that side and half of it's on this side, but the mean value is going to be dragged, in this case, towards the left. Now, for the crazy distribution, who knows what's going to happen? So they might be close together, they might be far apart, I don't really know. So I've kind of just drawn them there, like there's the mean is on the left and the median's on the right a little bit, but they could be anywhere. It doesn't really, there's no rules about it being on the left or on the right. The point is here, if they're spread out apart, if the median and the mean are spread out apart, quite often the median is a better representation of where the data are. Like for this one, most of the data are down here, and that's where the median is. There isn't very much data up here where the mean is. Same thing here. Most of the data up here where the median is, but there isn't very much data where the mean is. Then down here, who knows what's going on there. So I guess the moral of the story here is, regardless of what sort of distribution you have, the median is usually a pretty good indicator of where most of the data are. So as far as measures of center, I know some textbooks will tell you, well, if it's symmetric, use the mean. Well, I would argue that if it's symmetric, mean and the median are about in the same place. So in general, I think it's makes more sense to use the median when you're talking about the center of a distribution. Okay, this is a little bit harder to draw, but let's talk about things like the measures of variability. I'm trying to erase much of this red as I can, but some of it's going away, some of it's not. Anyway, the measures of variability we want to talk about, that we talked about in the last lesson, are the mean absolute deviation, that's one, the range, that's two, and the interquartile range. Now in a couple of years you'll learn about this cool thing called the standard deviation, but it's a little bit beyond the scope of this class, so we're not going to learn about it right now, but it's very similar to the mean absolute deviation, just kind of a little bit more complex of a calculation. Okay, I don't know how to really represent these from a drawing perspective in order to make them make sense. So here's what I'm going to do. I'm just going to write down all of these measures. So we've got the mean and the median. Those are the measures of center. And then I'm going to have mean absolute deviation, the range, and the inner quartile range. And then I'm going to say affected by outliers, because really that's all we're really talking about. If you have outliers in your data, they're going to have an effect on some of these measurements, and others, the outliers won't have an effect on them at all. So which measurements you use depends mostly on whether the other outliers are. Okay, mean. Is the mean affected by outliers? We've already shown that in a skewed distribution, the mean is dragged towards the direction of the skew, so this would be a yes. Whereas the median, is it affected by outliers? Well, not really, because the median is just the middle point. It doesn't matter if the stuff on one side or the other is close or far away from the median, it's still going to be the median. So the median is not affected by outliers. So symmetric data, mean is okay. Non-symmetric data, I'd use median. Even with symmetric data, using the median is okay, like I talked about before. Okay, mean absolute deviation. Let's skip that one for a second. The range, is the range affected by outliers? Well, think about it. That's what the range is. It's the outliers. It's the very, very, very smallest value and the very, very biggest value, the distance between those two. So is the range affected by outliers? I'm going to put yes with an exclamation point, because frankly, that's all the range is the outliers. Okay, what about the mean absolute deviation? This is going to kind of fall into a maybe. Here, it depends how severe the outliers are and if there's any space in between the outliers and the main pile of data. So I'm going to just call that one maybe. But the interquartile range, is that affected by outliers? In most instances, the answer there is no. So once again, is your data symmetric? If it's yes. If it is symmetric, then you could use the mean absolute deviation or the interquartile range, either one, to kind of measure the spread. You could also use the range, but it's really worst case scenario. If your data is not symmetric, if there's skewness to your data, then you should probably use for sure the interquartile range, the IQR, or possibly the mean absolute deviation. But I wouldn't use the range at all, because that just gives everybody a skewed sense of what the spread of your data are. For instance, let's suppose you're a big fan of Major League Baseball. And I don't know, let's see, in Provo, I don't know who your minor league baseball team is, but we have a baseball team here in Arizona Diamondbacks. So let's suppose they play 162 games next year, and most games they score, probably an average of 4 or 5 runs. Sometimes they get more, 7, 8, 9 runs sometimes. A couple times they get shut out during the season, probably more than a couple of times, so they get 0 runs. But one game was just a crazy, crazy, crazy game, and they had 23 runs in one game. And the second most runs they scored in any game the entire season was only 9. So you can see there's a huge distance between 9 and 23. Well, if somebody said, hey, what was the range of the Diamondbacks scores last year? Might say, well, it went from 0 to 22, so the range was 22 runs. And anybody just listening to that might think, wow, that's a pretty big range. But in reality, you're taking the very, very worst case scenario of the 0 runs and the best case scenario of the 22 runs and saying, hey, that's my range. But they never scored more than 9 except for one game. The other 161 games, they never scored more than 9. So range can really give a skewed sense of what the possible values are, okay? If you went to a company and said, hey, what's the range of salaries here? Well, some of the guys working on the line, they only make $10 an hour, so that's about $20,000 a year. But the guy who owns the place, he makes $7 million a year. So the range of salaries here are from $20,000 to $7 million a year. Truth of the matter is, the guy who owns the place is making the $7 million. Maybe the most he's paying anybody else. Maybe the vice president makes $150,000 a year, but everybody else is making $20,000 to $50,000 or $60,000. So to say the range is from 20 to 7 million, 20,000 to 7 million, it kind of skews what's really going on in the company. So you have to be very careful about using the range. Anyway, that's it for my lesson today. Have a great night, and we'll see you tomorrow.